This is an updated vlog entry on the research that I've been doing on an uncensorable API over IPFS. So this is going to introduce and demo a new code repository that the Permissionless Software Foundation is putting out called IPFS Service Provider. So what I'm going to do is demo this, show how this builds on top of previous work, which I'm going to recap here shortly. And I'm going to show how to use the new Json Rpc for communicating between peers on the IPFS network. This allows IPFS peers to provide web services, so like any valuable service that you can do today over the web, like compute as a service, storage as a service, basically AWS's whole business model. This can now be piped over the IPFS network using a Json Rpc to replace the traditional REST API. And so yeah, it's an IPFS-based replacement for the REST API, and it's based on the Json Rpc. So let me recap, because this is just one new milestone in a fairly long trail of research. So first of all, I am Chris Troutner. I'm a member of the Permissionless Software Foundation community, or PSF, and it's an open source community whose mission is to make it easy for individuals to protect their privacy, circumvent censorship, and engage in economic activity. So this research is in that spirit of protecting privacy, circumventing censorship, and engaging in economic activity. There's a body of research that I've covered on my blog at troutsblog.com/blog. And I really started putting this together with this first article, IPFS API, where I lay out the idea. I introduced the problem that I experienced, which was I produce a web wallet for Bitcoin Cash at wallet.fullstack.cash. And a woman in China wanted to use it. It was banned. The front end was distributed over IPFS, so that worked in China in terms of scaling, jumping over the Chinese firewall. But it wasn't functional because it relied on a REST API, which is easily blocked by a firewall. And so that was the original motivation to develop a protocol that could run on top of IPFS, because IPFS is naturally good at tunneling through firewalls and eluding attempts at censorship. And building a service provider system where in this picture on the left you have services, and on the right you have consumers of those services. And that's really the general problem that this technology is trying to solve, is how do you circumvent a lot of the conventional censorship that works well in terms of censorship on the original web using IPFS, and circumvent a lot of these censorship techniques that state and corporate actors who are deputized by the state use today. And basically, how do you allow two people to peacefully interact in a trade in a way that no state or corporate entity can get in between, and hopefully is not even aware that it's happening because it's end-to-end encrypted and private. And so this problem is what's solved by the software that I'm going to share today and have been sharing. So in a previous blog post, the last one I put out a couple weeks ago, I introduced chat.fullstack.cache. And this is there's two videos in this article. The first one is just a non-technical video on how to use chat.fullstack.cache. It operates as a very clunky instant messenger, but the reason I created it is just because it was the simplest display of the technology that I could come up with. So it's really just a developer tool and a proof of concept. So it's not intended to be a refined product. The second video is more for technical people, JavaScript developers, and I discussed the ipfs-coord library, which is at the heart of the end-to-end encrypted chat that is happening at chat.fullstack.cache. And then I introduced the concept of this Json Rpc. And so if you have chat, you can implement a Json Rpc, which is a way for two computers to exchange data and as well as payments, and basically can replace. You can then have a shot at replacing the REST API, which is at the core of Web 2.0 technology. And so fullstack.cache is another business that I maintain, and we have this concept of this cache stack, which is how you interact with the Bitcoin Cash blockchain. And that REST API is just critical at abstracting away the lower level details of the indexers and the full node. And this same pattern is used, across the industry, like from YouTube, Twitter, every major website you visit that's a Web 2.0 website, like Facebook. They use a REST API. The REST API is what gave birth to the Web 2.0, in effect, if not technically correct. So the fact that we could replace this with IPFS using a more censorship-resistant network is kind of a big deal. So let's get back to the slides. So with that, let me just jump into the demo and show you, enough talking about it, let me just show you. So I'm going to bring up chat.fullstack.cache, and the software that I'm presenting today is this IPFS Service Provider. So it's on GitHub, out in the Permissionless Software Foundation GitHub directory, and the repository is IPFS Service Provider. And I'll go over the README here in a minute, but there's an examples directory, and in that directory is a README with a bunch of Json Rpc examples. So that's what we're going to use today to demo this technology. So I'm in chat.fullstack.cache. I've created a Bitcoin Cash wallet, which you have to do before the app will work. Otherwise, when you click on the status, it'll give you an error. Oh, just like that. That's exactly what it will look like, which is odd because I did create a wallet. But I will just clear my local storage. And then create a new wallet. And then reload the page. There we go. Now we're off and running. And what I'm waiting for is for the IPFS node in this web page to reach out and contact the IPFS service provider. So right now the ipfs-coord library is doing its coordination. So this, I just happen to know, these names are going to get better, but this, I just happen to know that this XVJ peer is the service provider that I've set up. And I can now start sending it these Json Rpc commands. And the communication between the node that's running in the browser and the node that I'm talking to is end-to-end encrypted. All communication, so it's important to point that out. So if I copy these examples, I'm just going to copy those to a blank screen. Actually, I think I can just... this is the same example README just opened in my text editor. Oh, you know what? I'm going to start at the top, and I'm going to create a new user. So let's take a look at this Json Rpc. So there's this RPC header. This is an ID. This can be any number. This is automatically filled out by the service provider. I'm calling the user's method, and I'm calling the create user endpoint. And I'm going to create this. In fact, I'm going to change this to 678. User 678 at test.com, a name and a password. These are the minimum required amounts. So I'm using the chat app as basically a developer tool at this point. Normally this type of communication would just automatically happen behind the scenes between two apps. But this is the point of this video, is this Json Rpc. As you can see, the node on the other end responded to my command to create a user by creating a user and in the database and giving it back. And I can go through the rest of these examples to do basic CRUD creation and user of. So I can authorize my user. That gets me a new JOT token, which I then use on some of these other endpoints, which are restricted to a authorized user, like update user. You wouldn't want a user to update other users, so the user either needs to be an admin or the user that's trying to update themselves, and so that comes in through the JOT token. And this is all, I'm going over this pretty fast because this is the same convention used in REST APIs. This is the same convention. If you're a JavaScript developer who is familiar with building REST APIs and web services, this should all be familiar to you. These are the same industry standards. So let me go ahead and authorize my user again. What did I set him at? 678. User 678 with password. So I'm going to send this in. And you notice here I'm even using HTTP status, same like status code. So 200 means it was successful. And so there I'm authorizing my user, and it's returning a JOT token. And I'll use this JOT token in future calls because now I'm authorized. Basically, I can just pass this JOT token. And what looks like clear text here actually isn't. It's only clear text in the browser because, like I said, all this back and forth is end-to-end encrypted using the Bitcoin elliptic curve encryption. Same exact encryption that's used in Bitcoin to send and receive money. That's tied to this Bitcoin Cash address. That's why we needed to create a wallet first. Oh shoot. That's what happened. So we'll let this reload and find those peers again while we craft our next. So I had mentioned that update user is restricted to an authorized user, public. Like you can't just use it publicly like you can with the create user or the authorized user endpoints. You have to pass in your JOT token. So we have our JOT token. I'm going to paste that in right here. And oh, you know what? I don't have my user ID, and I need that. So let's see. If I go back here to this node, I'm going to reauthorize my user. That'll give me a new JOT token, which I'll replace this one with. But it also gave me my user ID. Okay, so now I can use this restricted endpoint to update my user. And let's say I want to update his name to test999. So it's going to update from test678 to test999, or actually testy tester. That was the name. We're going to change that to test999. This is a bug in IPFS. Okay, so let's recap here on what happened. That was a little hand wavy. So let me just explain, because what I'm demoing here is just the very raw basic replacement of a REST API. So if you don't have a strong grasp on the fundamental technology between HTTP calls like GET and POST, that make up a REST API, and like the types of status codes that are returned, like 200 or 404 or 422. This is the level of the technology that I'm at here now, is actually replacing that layer of the REST API. And again, it really helps to think in terms of layers of a stack, where you've got the REST API and then probably a JavaScript library running in a web browser, and then the business logic on top of that. And that's what makes up a phone or a web app. And so this REST API represents the server side of things. And so the fact that we've replaced it with IPFS, there's several things going on, and I recommend for the IPFS specific things, watch this video on IPFS coordination, and I go into detail on the pub sub and the OrbitDB peer-to-peer database that's being used, as well as the Bitcoin Cash end-to-end encryption and the addresses that are used for sending coins and tokens and payment in general. So all the basic elements here, including privacy. So you've got privacy, censorship-resistant, the ability to communicate privately, and the ability to send payments. So you have everything that you need in order to do basic trade of any kind. You may need additional things like addresses, like mailing addresses if you're dealing with physical objects. But all the basic ingredients here are there for any two computers on Earth to find one another, connect, and do trade. So what's new here is this Json Rpc. And that's what I just showed the demo. So again, that's something, if you're not familiar with the Json Rpc, it's based on these types of strings. It's just passing strings. It's a way for two computers to exchange data, and it's a direct replacement for, whereas a REST API is both this API back and forth. It rides on top of HTTP. Here we're demonstrating JSON riding on top of that IPFS-coord encrypted communication, and that's what's replacing the REST API. So what is this technology good for? What can we use it for? What can we do with this that we couldn't do before? As I said, the main advantage of this is that it's nearly, if not totally, uncensorable. That someone with a Raspberry Pi in Nigeria can offer a service storing files for someone in China, and those two computers will be able to find one another, coordinate payment, and communicate with one another and pass data and money, and it should be nearly impossible for any government firewalls to stop that from happening. And so some of the services that I think are valuable for this that I plan to work on going forward is circuit relay as a service. I talk about this in one of the previous videos about circuit relays and how they're a critical piece of the censorship resistance of the IPFS network. It's what allows the web browser to find the service provider, because they can both talk to a third circuit relay computer that can act as a relay and route the traffic. And in order for this to be robustly censorship resistant, we need to have multiple circuit relays. So it would make sense. I can see a scenario in the future where, say, the Chinese firewall, which is largely algorithmic and is constantly improving itself with AI, it will probably figure out how to locate and block IPFS circuit relays that are open publicly. And so there's probably going to be a need to sort of on the fly negotiate a circuit relay, and that can happen with the JOT token that I just showed. You can pay Bitcoin Cash or a token to receive a JOT token, which then would unlock the address of a circuit relay that your node in a highly controlled environment like China can use to break outside of the firewall. Just like you would use a VPN, but this is much more fluid, and the concept's roughly the same, but the actual nuts and bolts are different, and this could be a much more algorithmically driven, on-the-fly sort of thing, rather than the way VPNs are used today, where you go and you find a provider and you pay them and you give them your email, and it's a very slow manual process. And then you you run special software to set up your computer to run the VPN. That would all go away. This would just your computer would just automatically negotiate it, and if there's payment required, then it would just tell you, hey, put some Bitcoin Cash in your wallet, and then we can get this done. So that's one service that I think just right off the bat is needed and is completely possible with the technology as it stands right now. There's this other idea that I'm very excited to explore called that I'm calling pay-to-write databases, or P2W databases. And this is really based on OrbitDB, which is a peer-to-peer database. And I've been researching their access controllers, which define the write access to the database. So I've managed to create a prototype where anyone can write to the database, but you have to prove that you've burned an SLP token on the Bitcoin Cash chain. You provide the token, the transaction ID as proof. And so anyone can write, but only if you have proven that you've burned the token. So that makes the token more valuable. And it prevents spam, and so that's a very clear incentive for an organization like the Permissionless Software Foundation to support, to build software and support that software over time around these types of databases, because if their use directly makes the token more valuable. So I'm attracted to that very clear incentive model. So a couple apps that I plan to use this in the near future is torlist.cash. That's going to be a website that will be a curated list where people can advertise Tor-based websites or IPFS-based websites, or like the .eth unstoppable domain type websites, as well as clear web websites. But the point is it puts them all on equal footing, and it uses this uncensorable peer-to-peer database that many people can tap into and add to, and can build their own services around. And so that's probably the first thing we're going to roll this out, and then immediately followed, or probably in parallel to that, we're going to start working on a DEX, a decentralized exchange. And at first it will focus on the Avalanche, Bitcoin Cash, and eCash, which is also the ABC, Bitcoin ABC chain. They'll be rebranding into eCash. And so those are the three chains I know the best, and the Permissionless Software Foundation has the most experience with. So we'll focus on that. That'll also include tokens on Avalanche and tokens on Bitcoin Cash. So we'll create basically an order book in the database that, again, anybody can add an order to by burning the PSF token, and then anybody can display that data in many different ways, and basically it will be an order book, and it should be uncensorable and decentralized. So if this has piqued your interest and you want to join me in this research around a replacement for REST API servers using IPFS and Json Rpc, this is where you can find the code that the node that I was just talking to. You can just install this and run it and set it up, and you can also just use chat.fullstack.cache to interact with it. You'll see it pop up. One thing that I haven't covered is this is largely based, so now that I've given the demo and sort of explained the reasoning why this is valuable and what you can do with it, I'm going to dive a little more deeper into the code, so that other developers can be comfortable installing and using this and navigating the code. So this is based on this Koa API boilerplate, which there's a link here in the README. But this is this go-to boilerplate that I've used for years as a freelance developer to build REST APIs for clients. Whenever I have an entrepreneur come to me and they're like, I want to build a phone app to do X, usually this API boilerplate is involved. And so I highly recommend checking that out, because everything that can do, this can do, because it's a fork. And it's designed for building REST APIs, but what this service provider code does is it lets you build the business logic once and then attach that both to the REST API and the IPFS Json Rpc. So you have two different transports for accessing the same business logic. So you really can run a conventional REST API server with this software and then just mirror it on IPFS, or you can choose one or the other. So that's one big advantage of this boilerplate. Also, it is a boilerplate, so it's intended to be forked to build, to just sort of bootstrap or launch a new project. So it's got nearly 100% test coverage. It's got pretty good documentation, which I'm going to go over some of it, and we're going to continuously improve the documentation. What the basic idea behind this REST API is it has a Mongo database. So that's a big concept in Web 2.0, is having a web connected database. It uses JOT tokens for authorization, which is a very modern industry standard way of accessing APIs, and it allows you to quickly and easily implement CRUD endpoints. So CRUD is an acronym for create, read, update, delete. So those are like the basic things that you would do to something in a database. You'd create a database model, and then you would use those REST endpoints to manipulate that model, create, read, update, delete. So that's the basic idea behind this the Koa boilerplate, the REST API boilerplate. And so all we've added is this Json Rpc over IPFS. And the ipfs-coord library, which is what lets the nodes find each other quickly when they go to chat.fullstack.cache. So it's really just these two things. That's the only difference between this and the Koa boilerplate. So let me talk about the structure. The file layout. So when you look at these files here, these directories, this is what I'm going to talk about. There's a little map to them here. And so in the bin folder is the server.js file, and this is the main program that is run when you do npm start. And there's a config file. There's a common file which has all the common settings and environment variables. And then there's these environment-dependent files. So whether you're running like in a test mode or a production mode or a development mode, the default is development, except when you do like npm test, it runs this test environment. So what I'm going to cover this stuff pretty quickly because this is all in the Koa boilerplate. So I'm assuming that if you're really sincere about using this, you'll go study that first. The passport is for the REST API authentication. Production is a Docker file, so if you want to run this in production, this is the basic blueprint you'd need to produce a Docker container. The source directory and the test directory are really where the magic happens. So the test directory holds the tests, and I need to flesh that out because there's actually a pretty sophisticated... While I was doing this project, I decided to refactor the tests, so it's pretty sophisticated. There's in the unit test directory, there's separate directories for the business logic, the Json Rpc, and the REST API, and then mocks, which are used in the unit tests. But it's really the BizLogic, Json Rpc, and REST API. So I break all the unit tests out and the structure of the files because this project is designed to have the business logic segregated from the different transports that are used. That lets you leverage either the REST API or the Json Rpc to access the same business logic. So that's why they're broken out in these ways. And then there's these end-to-end tests, which really thoroughly test the authorization, the user CRUD calls, the contact, and the logging. Contact is like email contact. You can have this thing send like email notifications. That's all built in. And then there's a utils, which is test utilities, and then eventually there will be an integration directory here for integration tests, but there aren't really any of those in this boilerplate. Yeah, and then so that leaves just the source directory, which is where the business logic lives. So there's an RPC directory, which is the one that is really the magic for this project. this is the boilerplate Json Rpc for over IPFS. So that's the main thing that sets this repository apart from the Koa boilerplate. Models is database models, middleware and validators and modules. Basically, middleware and modules, these are for the REST API. So they'll probably get moved to a REST API directory, like there's an RPC directory. And then lib is the business logic. So that's basically where the meat of the software lives if you want to start familiarizing yourself with it. These are the NPM scripts. Start, run dev, run docs to generate API documentation, npm test to run the Mocha tests, and then these sort of Docker commands that you can run to build a Docker container. And yeah, so the tests that I built for this follow the patterns in this YouTube video. This is on my YouTube channel, Chris Troutner. And it's called JavaScript Testing Patterns and Best Practices. And so if you watch this video, it will introduce the design patterns used in this repository, and it will really help you understand the code if you understand the pattern that the code is written in. And then there's the Json Rpc specific code. So if I go into that, that's in source RPC. And so there's this index folder, or this index file, a validators file, and then there's an auth and a users. I guess I'll just go over both of these, and an index file in each of those. So this is sort of a minimalist install, right? The main point of these files is to establish the design patterns that you would follow to then add additional endpoints for whatever business you want to specialize this for. And so in this index file, this is basically the main library for the Json Rpc for this program, and all the other files I'm going to show, they get loaded into this sort of master file. And so it's I use JavaScript classes for everything. Everything's a class because they're much easier to test. And it sets up a main router that takes that raw JSON string coming in. Make sure it's a string, otherwise it just quietly exits. That way you can still use the private chatting feature, as long as it's not like wrapped in a type of JSON-looking string. It's just going to be ignored. And it gets parsed, so basically converting it from a string into actionable JavaScript objects. And if it can't figure out what to do with it, it responds with this default response, which is right here. It just says, error, input does not match routing rules. It doesn't know how to route it. And then here's the router. Right now there's just an auth route and a users route. So auth for authorization, users for CRUD endpoints on user models, database models. And so right now those are the only sort of routes that it responds to, and it just routes them to that index file that's in those directories. I'm going to talk about those, but first I want to talk about the validation library. I thought I had loaded that. So this Validators Library, this has two methods in it. It has ensure user and it has ensure target user or admin. And there's a mirror of these on the REST API side of the code. They do the same. They're named the same thing and they do the same thing, but one does it for REST and these ones I'm talking about are for the RPC. But they're basically middleware, and they make sure that the person passes in an API, the JOT token, and that the user model they're trying to modify, in this one, it ensures that the user that they're trying to modify is either that they are that user that's being modified, or they're an admin and thus have admin rights and can modify other users' information. And then this one is just a general ensure user, so it just ensures that they pass in a JOT token. So this is how you restrict you define an endpoint as either being public or private, either open to everyone or open just to authenticated users. And you'll see these so this is an example of the users. This users file that I'm going to show right here, this is the main pattern that you would want to follow. You would want to fork this file if you're going to start adding new CRUD endpoints or new web services. This is going to have basically the template that you'll want to follow. And so it encapsulates these dependencies, and then the validators files in there. And then here's the router. So it's going to read the endpoint parameter. If I'll go back to these JSON. So here's an example. This was the update user. So it was the user's, endpoint or method, and then the update user endpoint, which is in the parameters. So that's what it loads, is this params endpoint, and then it routes to one of the handlers based on that value. So that one I was just showing is the update user. And here's where it calls that validators class, and it's ensuring that the person making this call is either the target user that they're trying to update, or is an admin. So if you have like user A try to modify user B, this would throw an error and prevent that from happening. But if user A wants to modify user A's database model, like change their name or their email, that's okay. Or if an admin wants to update user A, that's okay too, because they're an admin. And so once it passes that check, it goes to the update user handler, and update user passes the information along to the business logic, and so that's the same business logic that's used whether you're using the REST API or the Json Rpc. And then it returns a payload, whether it succeeded, or a payload if an error was thrown. And so it's, again, I'm using like these HTTP statuses. So 422 is unprocessable entity, 200 is success. I'm also passing like true or false for success. If there's a message, like an error, then I pass an error message. And just it responds with both an ID, and then I manually put the endpoint in here, just so that the user knows that which specific call is being answered and what specific endpoint was called. And because Json Rpc does not guarantee, I mean, it's designed to withstand lossiness. So like if you request some information from a server and it just never responds, that's okay. Like if you send the command again, each command is has a unique ID, so you know when the response comes back, like which command you sent that the response belongs to. And anyways, this pattern that I pointed out of returning a payload, both as if there's an error or if there's a success, and then passing data on to the business logic, this is the pattern that I want to point out, is that these methods, they're only concerned with the Json Rpc. All business logic is handled by another library. This greatly simplifies the unit tests, and it simplifies the code, because you can just basically copy and paste the same pattern over and over again. You don't really have to think too hard about this in order to create new endpoints, and that's the point. Is you should just, without needing to know any like super in-depth knowledge of this stuff, you can just get going quickly by copying and pasting. Just fork this file and modify it for the endpoints that you need. And then the business logic is of course up to you, because that depends on what you're building. And so that's basically the pattern there. The tests, I won't bother going into the tests, because like I said, that they follow the same pattern that's in this YouTube video. So this is the introduction to IPFS Service Provider. I am really excited about this. I'm going to build a bunch of services around this to make money. And I encourage other people to do the same. Join our community at the Permissionless Software Foundation, psfoundation.cash. You can watch this video halfway down the page or read our business plan. But we're a community of JavaScript-focused developers solving business problems. And as I said before, our focus is to make it easy for individuals to protect their privacy, circumvent censorship, and engage in economic activity, because that will create prosperity and that will help everyone, and that is our mission. So we're looking for like-minded people and like-minded developers to join our cause and to make money with us. So I hope you'll consider doing that.